All right, good day, everybody. This is Jason Straight with the Cloud Pass Virtual Group. Today, our presenter is David Pless, and he's going to be talking about Microsoft Certified Azure Fundamentals Bootcamp. Before we get going today, I just have a few announcements that I want to run through, and then I will hand things over to David. So the first thing is if you are not currently subscribed to the Cloud Pass group, I would recommend doing so. That gives you the best ability to find out about upcoming presentations and any changes to the schedule, which do sometimes occur because life sometimes occurs and the presenters either can't make it or we need to rearrange some of the schedule from time to time. Talking about sessions, we do have quite a few sessions coming up over the next couple months. We're still clocking away at about 2 sessions per week on Tuesdays and Thursdays, usually at about 1700 UTC. So check out the schedule, the sessions that are coming up, and we're always adding new sessions to the calendar. If you are interested in presenting, I'm always looking for more presenters because time keeps going on. We keep having openings, so I'm trying to fill up the calendar all the way through the end of March right now. So if you are interested, please reach out at cloud@pass.org. Alternatively, you can go out to the cloud.pass.org website and click on the call for speakers there and fill out the form, and I can get you scheduled. Coming this fall is Pass Summit 2019. If you have not yet registered, we can get you a discount to that registration using our virtual groups discount code. And that can save you up to, well, that saves you $150 US off of your registration fee. Additionally, with the end of the year coming, Pass is interested in everyone's opinions on how Pass is operating and what future programs and offerings they should be putting together. So if you have the time, please go out to SurveyMonkey and take the Pass membership survey. That is open until October 2nd, and as a thank you, there are going to be a few gift cards that Pass is giving out for that. Additionally, with the end of the year, we also have the Pass Board of Elections coming up. The applications for the Pass Board just opened up a couple of days ago, so if you are interested in participating and being a member of the board, now's your opportunity to get into the nomination and nomination process. I'm a candidate for the Pass Board. Additionally, for the Pass Summit, there's always the Passion Award that gets awarded, and this award basically helps recognize people that that are in the community that are helping other professionals connect, share, and learn. The nominations for this do close today, so if you have a local use group, chapter leader, or somebody that you've met at a SQL Saturday that really kind of helped you out, this is a great opportunity to help recognize them. And then this virtual group is part of a number of virtual groups that Pass helps put together to help other folks learn more about Microsoft data platforms and Microsoft data platforms. These focus on different areas, such as this one is focused on cloud, others are focused on, say, data science, and if English is not your native language, there's a few others that focus on specific languages like Global Spanish and Global Italian. Throughout this session, you may have some questions. There is a Q&A area on the GoToWebinar that you can type in your questions. Throughout this session, there are some additional presenters on that will help answer some questions as they come up. So please have them, please put your questions in throughout. And if there are any questions left over at the end, we'll go over them with David. And with that, those are all the announcements I have to get this session going for today. So our session today is Microsoft Certified Azure Fundamentals Bootcamp with David Pless. And let me make David the presenter.
Very good.
All right, there you go, David. And I will just confirm for you that when things, yep, I can see everything. So I'm going to mute myself so I don't interrupt you.
So do you see one screen or two screens, or which screen do we have?
I see one screen. I see the one screen with the Fundamentals Virtual Bootcamp with the turning gears.
Perfect. Okay, so how do I minimize?
There's a little pink, orange arrow on it.
Okay. A little learning curve here for me for this thing, but it looks really cool and I like it. All right, are we ready? Okay, so yeah. Hello, perfect. So hello everyone. In this session, we're going to cover the areas to focus on preparing for the AZ900 exam. We're going to have a primary focus on content areas to study, resources that are available to you. We're also going to walk through like really the key components to focus on. And let's see if there we go. Outside of this session, if you have an opportunity to take the AZ900 course from one of our learning partners, I also highly recommend that you take that as an approach, because it's a full day's worth of training specifically around the course's focus. We have 90 minutes to kind of do this virtual boot camp today. Be aware the AZ900 exam really focuses on Azure Fundamentals. Right? So when we say this, we're taking an approach, like I like to say, an inch deep and a mile wide around capabilities and core services and functionality in the cloud. So you're going to have this approach around cloud services and really how the services are used, and that's really what the exam is focused on. So I would not consider this to be a technical exam. This is certainly not a deep dive in any particular area. In fact, it was intended for those with non-technical backgrounds. If you look at the exam objectives, you'll actually see that. So as I tell everyone, if you've been using Azure and somewhat experienced with the Azure portal, I actually recommend taking it very quickly, actually very soon. Maybe even if you're comfortable with the topics that we're talking about today, you may want to take it pretty early. If you're looking for an area to brush up on further, I definitely recommend taking a look at one of our instructor-led courses and actually some of the references that we're going to have early on. A little bit about myself really quick. I am an Azure technical trainer for Microsoft. I've been a premier field engineer. I've been an MCS consultant. I was at Intelenet for a couple of years as an MCS consultant before moving to Microsoft as an MCS consultant. Then I spent 10 years as a PFE. Cover everything from SQL Server performance tuning and optimization to the full reporting stack, high availability and disaster recovery with all these unavailability groups, and then, of course, moving into the cloud, all of the platform as a service technologies that are data, with a particular focus on the relational side, SQLDB, managed instance, SQL Server on IaaS, and any of the monitoring advisor log analytics and the tool sets such as that. Okay. So a couple of session focuses. We're going to talk about cloud services and models. We're going to discuss some of the building blocks of Azure and how they relate to each other. We're also going to cover, well, I call it like a buffet, right? A buffet of the Azure services and products and the tools that we use to support these technologies. And if you really think in the terms of, like I like to say, like a buffet of these technologies and how they're used, that is really going to help you with that kind of mindset for the exam. Like, know all my nouns and verbs and how they apply to what I'm looking at in Azure, as well as being familiar with the Azure portal. So also walk through the security topics to focus on. There's a lot of different ways to secure resources in the cloud, on-prem, and in hybrid scenarios. I recommend looking at this in the lens of defense in depth and remembering that these technologies, what they're designed to do, rather than getting into the myriad of different properties. Look at this from a, what does this technology do and how do I secure this from a defense in depth lens? That's kind of be the best practice there. Outside of that, understanding billing, service level agreements, the service life cycle, and supportability is another big portion of the exam. I want to kind of show you as well as the certification areas and the breakdowns. And this may actually, I mean, I verified this before, just to make sure that this is right. And I definitely recommend going and looking at the exam objectives so you understand, like, this is what you're actually going to be tested on. But this is the weights that are broken down for this exam, and it may seem surprising. So don't underestimate pricing and support. That's actually a fairly large portion of the exam. Certainly, you don't want to underestimate anything around security, privacy, compliance, and trust. But they're pretty evenly weighted across in these areas, and this is sort of the focal point that we're going to have in this boot camp, and what you would also see in one of our instructor-led courses. So I wanted to give some quick, normally I would do this at the end of a presentation. I wanted to do this at the front. One, we have a whole lot to talk about. But if you follow this approach, you're going to be well on your path to passing this exam. Again, around the certification areas, if you go to this link, this is a description of the exam, what skills are measured, how to schedule it, links to self-paced learning, and a full guide to the training that's going to be actually on the next slide that I have. I highly recommend, if you don't have access to Azure currently, get a free account. Get $200 to kind of go through the portal. Get familiar with the portal. Just spin stuff up really quick, and then just click around. Maybe create a sample database. Walk through some of the tutorials that actually built directly into the portal. It's like when you create a search for a resource, you say, "Hey, do you want a tutorial of this? Do you want to walk through on this?" Take a look at it. Remember, it's not going to be a deep approach, but this is an awareness of what is in the portal and how to get to things. And I think that would actually be a very good thing for you as well. The Microsoft.com/learn, they've done a fantastic job of putting a lot of this stuff together. Whether it's around data science or data engineering or just SQL focus in the cloud, any number of things. We actually have a whole section on Azure Fundamentals. They did a really good job with it. I think it's like 9.5 hours of just fundamental content, which is like the length of a day course, right? So you can go through this as well and find a lot of what you're looking for just going to that path. And then, of course, if you prefer an instructor-led experience, you can go to this link here. You're going to see, this isn't specific for AZ900. You'll see all kinds of courses there. I think for AZ900, it's like there's also language support for Chinese, Japanese, Korean, and of course English. But there may be some other languages that are supported there as well. But just take a look at that, and if you're interested in the instructor-led approach, that's available as well. This is the guided path. This is a screenshot I did from this, and you're going to get this out of that direct link on the previous slide. But when you go over here, you can actually click directly into the areas that you want to focus on. And, it could be an hour on these particular topics. It's well broken down, very step-by-step, very methodical, telling you exactly what you need to know. And 9 hours and 35 minutes of content for 12 modules. That's really, really cool stuff. Okay. Also, and this is a slide we added in. So Microsoft Learn provides a interactive way of combining short step-by-step tutorials, browser-based interactive coding, scripting, and task-based achievements to help you develop your technical skills while earning these achievements. Take a look at the link here for Azure Fundamental Pass to get your free online training. And then in the next 5 business days, you'll get an email from Pass with your free voucher code, and then you should use that code in the next 2 months for that voucher. Sooner the better. As you go through the content and it registers in your mind, and you start getting familiar with these core concepts, I recommend going ahead and taking it sooner than later, because it's just going to increase your opportunity to pass the exam. Okay. So let's get into our key cloud concepts. So in this section, we're going to be talking about understanding the cloud services and their benefits, key terms that you're going to encounter. In particular, you'll see this on the exam. You'll see this in some of our documentation: private, public, hybrid cloud models, IaaS, PaaS, and then software as a service scenarios. Okay. And this is certainly a big portion of the exam focuses on this. So just in general terms, cloud computing, this is a delivery, server, storage, databases, networking, software, analytics, a whole lot more over the internet. And then Azure enables innovation, using these resources with a strong focus on economies of scale, being able to do something very quickly and taking advantage of the opportunities that we have, the resources we have in the cloud, being able to create something very quickly, being able to tear it down, recreate, redeploy with very little upfront risk. And that's the key capabilities in Azure. So these characteristics, there's some key terms that I want you to be aware of. And first we'll talk about high availability. Now I want you to think about, as we go through these, what you would also have to do on-prem to achieve some of the same kind of things. For high availability, in particular with Azure, it's the ability to keep services up and running for long periods of time with little downtime. That's the key point. That's what high availability gives you. But this is always from the perspective of the user/consumer. So think about the hardware and the configuration that's needed to create that on-prem versus what you might have to do in the cloud. Fault tolerance. This is the ability to continue running after a failure occurs. And it's very similar and empowers high availability, but fault tolerance is created by having key redundancies. If a component fails, a backup can easily take its place, and resiliency is built into Azure products and services. Disaster recovery is the ability to recover from an event that has taken down a product or service, and recovery is tracked in the amount of data loss that can be tolerated and the amount of time it should take to bring the resources back online. So we commonly talk in terms of a recovery point objective, a recovery time objective. Again, Azure makes this very easy to do. The number of data centers that we have, the connections between those data centers, very low latency, and the data duplication that is driven in these technologies as well. Scalability is the ability to manually or easily increase computing resources to match a growing workload. It's very easy to increase or decrease scenarios as they come, as you need that flexibility. You can ramp up, ramp down, but you can also scale out. So it's not just a matter of quote unquote throwing hardware at a scenario. You can scale out as needed as well. Related to this is elasticity, and this is automatic scaling of resources. So let's say like a website gets a large demand and you need it to respond with additional capabilities to appropriately drive that workload for that particular spike. We also have strong global reach. This is the ability to reach audiences really anywhere. In cloud services, because of the data centers in the various regions across the globe, it'd be very difficult to do this on-prem, but we have a very strong capability being able to reach customers really anywhere. We also have strong latency capabilities between these data centers, and controlling latency is all about just reducing noticeable delays or slowness between anything that an application inputs and that the processing and then getting a response from that input. It is very easy to try to control that, even in hybrid scenarios over VPN or an Azure Express route. You have the ability to isolate and improve these situations. And this goes to agility as well. This is the ability to react quickly. And this is accomplished with flexible tooling, the portal, PowerShell, other methods, but you can easily allocate and deallocate resources as needed. And Azure is very strong in that regard. We also have predictive costs. Resources can be scheduled to scale, shut down. You can, there's a lot of budgeting and cost controls directly in Azure. You can see what your trends look like over time. Actually, I spend quite a bit of time looking at this myself to make sure I'm not going crazy with my own Azure spend. And it just gives me an idea of like, what I'm using and how I'm using it. Okay. And security. So many cloud providers, and this is kind of like not normally where people's thoughts go initially when it comes to Azure, but it's absolutely the case. We can provide better security services that you could achieve on-prem or for yourself. So Azure provides layers of security capabilities that stand on their own, such as denial of service protection, network security and application groups. There's firewall protection, and many of these capabilities are built into the platform as a service components, as well as like just-in-time access for virtual machines. So there's so much more advanced threat detection. There's so much more security capabilities that are built in. It's an area that I find extremely interesting as well. But you'll find that every building block in PaaS and every virtual machine and container from an IaaS perspective, a compute perspective, there's a strong level of security, all in line with defense in depth across the Azure platform. All right, so let's talk about some of the Azure building blocks and kind of some concept areas. So the concept of economy of scale, this is the ability to do things less expensively and more efficiently, operating at a larger scale in comparison to a smaller scale. And it gives you quite a bit of capabilities as far as, think of like a net new concept or an idea, right? You would like to test it out, but you don't want to have this whole huge risk of committing to a large amount of upfront purchase in order to test out this concept. Also gives it very flexible in terms of being able to quickly create a scenario, only pay for what you're using, and then collapse that scenario down. So innovation is driven via economies of scale and helping you control costs. Related to these concepts is CapEx and OpEx. And capital expenditure, this is the spending of money on physical infrastructure up front. This is how businesses are typically run or typically operate, right? So we have, and I'm sure we've heard the term, like if you don't use it, you're going to lose it, right? If you don't spend this money, you're not going to get the budget for the next cycle. And businesses are traditionally kind of in this mode to where we have to have all this upfront purchase. There's a lot of over purchasing. It's really hard to take that investment and actually show kind of true total cost of ownership around that investment. But companies are typically in this situation. Operational expense, this is the spending of money on services or products, and you get billed as you use them. And it's far more easy to control this kind of scenario. You get much better total cost of ownership around what you've actually created. And it's easy to kind of prune your approach and adjust your spend and adjust your needs very easy over time. When we talk about versus a platform as a service approach, you can constantly mold your application solution. Your customers they're consuming it at the software as a service level. What's happening behind that as you evolve your solution? You're not committed to any one approach. You can evolve over time. And that's one of the really strong capabilities that we have in the cloud. All right. So what this pushes us to, we've already been talking about this a little bit, is really the type of cloud models that we have: public, private, and hybrid. Organizations in this case will determine what's going to run in a private cloud on-prem or in the public cloud. So you may find applications, the application runs on-prem, but the database is stored in the cloud, right? Data warehouses could be stored in the cloud along with reporting for the business intelligence side of the house, while the OLTP application is kept on-prem, for example. You may have a scenario where hybrid cloud makes more sense to meet regulatory compliance situations. It could be a HIPAA compliant scenario. It could be like a FedRAMP, FedTech scenario for government assets. There are reasons why you may find that you need a hybrid cloud model for a deployment. Okay. So let's talk about our cloud services and just kind of compare, the cloud services against the models that we talked about. First of all, and this is usually the barrier of entry where most customers are bringing workloads. Why? Because they're used to the virtual machine level. They're used to working with Hyper-V. They're used to working with VMware. They have this virtual machine. In fact, their app lives on the virtual machine. So if they're going to move a workload from on-prem to the cloud, moving that virtual machine, quote unquote, first of all, they have the skills already. They're very familiar with it. And it's a very easy adjustment from a vendor perspective. For existing apps, this is the most common scenario that we have. What does this include? Well, any number of virtual machines. I mean, if you go in the Azure Marketplace, you're going to find everything. You're going to find from SQL on Linux to Windows to third-party virtual machine, you name it, it's out there. This also includes the components that support these scenarios. The physical data center that supports this from an IaaS perspective, but also all the technologies that supports these machines as well. Now, the next step is what I like to call the building blocks. And these are all this is perfect for net new development. This is perfect for stretch scenarios around analytics and big data, around IoT, any number of those kind of scenarios. It's also perfect for your NoSQL stores. Like if I'm trying to move, let's say, a Mongo database-based application or Cassandra-based application, I'm going to start looking at Azure, the Cosmos DB. Maybe I'm trying to move a data warehouse scenario. So we have Azure Data Warehouse is perfect for that. We have Azure Data Factory for our ELT-based extract, load, transform-based approaches, or that actually also has SSIS support as well. So we have all these building blocks that is perfect for these net new development scenarios that we call platform as a service. Now, what your customers will see, this is your software as a service approach. You're just consuming, right? Now, I doubt, unless you're a nerd like me, I doubt like when you're binge watching a movie or you're streaming music or whatever you're doing, that you kind of go, I wonder if they're using a platform as a service back components to drive this, or are they using virtual machines to drive this? Could be any number of them, really, right? So if you're the consumer of the product or service, whether you're streaming a movie, whether it's music, whatever the application is, right? What happens behind the scenes is going to continue to evolve. Usually, virtual machines is where things start. Your investment, your migration step is IaaS. And usually, more and more platform as a service building blocks gets introduced. And it's not just to control cost, but it's also to take advantage of more modern approaches that drive performance, drive security, drive high availability, drive disaster recovery, drive analytics, and any number of other additional scenarios, including IoT. This is kind of like the way the models get connected to each other, and the consumer lens you have amongst these cloud services. Okay. Now here we're going to get into what are the core services we need to be paying attention to? What are the terms around these data centers and on this availability scenarios? So we have our regions and our geographies. Okay, so in a region in Azure, it's made up of data centers located around the globe, with most of the general locations documented. Like East 2 is Virginia, and I can't remember which West 2. One's in California and the other one's in Washington. Like for most part, not the exact address, but you're going to see most of the time you're going to see these kind of documented. So this region is an area, a geographical area that contains at least one data center, and these are in close proximity and networked together via a very, very low latency network. Okay, and I looked the other night. There's like 50 regions in the world, with an additional four regions that are planned, and there's also some special regions that are treated a little differently. And I think it's good for us to be aware of these. So, like U.S. government scenarios, we have for any of these data centers, there's absolute complete physical isolation from the public data centers. There's no connection at all. In fact, can someone I'm hearing someone else on the line. If you don't mind muting, I would appreciate it. In fact, there are 2 government regions that are completely in undisclosed locations as well. And like for Azure government, this is going to be like the DoD Central. There's U.S. government, Virginia, Iowa, and there's others as well. Now, there's additional ones to be aware of. There's U.S. government China, which is operated by 21 ViaNet, and Azure Germany is operated by Deutsche Telekom. And those are the other 2 that are a little different. The geographies, these are data centers that are made available to end users by country region, and this is like grouped like Americas, Europe, Asia Pacific, Middle East, and Africa. And these geographies have 2 or more regions. Now, from an availability approach, okay, we have availability zones and we have availability sets. An availability set is a group of 2 or more virtual machines in the same data center. And this ensures that at least one of the virtual machines hosted on Azure will be available if something happens. Okay, this provides 99.95 SLA. So it's basically about 4 hours of allowable downtime, 4 hours and 22 minutes of allowable downtime per year. Okay, now each virtual machine in your availability set has a update domain and a fault domain that is managed by the underlying platform. The update domains are designed for patching, so only one update domain is updated at a time. And the fault domains define the group of virtual machines that shares a common power source and network switch. Availability zones adds to availability sets by adding redundancy with physical separate locations within an Azure region. And with availability zones, we have up to 4 nines of availability by our service level agreement. And what that means, so it was 4 hours, 22 minutes for availability sets. For availability zones with 4 nines of availability, that equates to like 52 minutes of downtime roughly per year. So you can see that that's a pretty big impact by having a solution in an availability zone. So kind of looking at this situation here, we have 3 fault domains. We have multiple update domains as well. And we have availability sets for our web layer, our line of business application, and our SQL layer, right? And if a fault domain were to go online, we'd still be up, still be able to maintain our applications, would still be functional. And if we were to update, let's say update domain 2, would also still be up because we have redundancy from the update domain perspective for our availability sets that are stretched across our fault domains. Okay. So let's talk about compute, data, IoT. This is all our core components and sort of like the buffet of technologies to be aware of. Again, I'm going to kind of plug the idea of going through the Azure portal, being aware of these. The nouns, verbs, just the awareness of all of these technologies is very key. And you're definitely looking at this in the platform as a service lens. So first thing first, no matter what you create in Azure, it has to be part of a resource group. You can think of a resource group really as like a container that allows you to manage all the resources required by your application in a single unit. So it's like a folder in Azure. So where every resource is created has to exist in one and only resource group. Now, personally, I love resource groups. Definitely recommend strong naming convention. It helps really kind of group things together. I love the idea. And one thing that I personally like to do is to pin a resource group to my dashboard. So I can just basically quickly see everything in that group and be able to reference it really, really fast, right? So like a resource group has a purpose, usually around a project or whatever effort that I'm looking at. And it also makes it a nice, easy container that can be moved. So I can move resources between resource groups. I can also take a resource group and move it to a different subscription, which is really nice. Okay. Now, our virtual machines, these are like, really, as we know, they're like software emulations of physical computers, right? That's what they are. And they're not any different conceptually than anything that we deal with on-prem. Like VMware, Hyper-V, the same concept. I'm logging into this virtual machine, I have access to this virtual machine, I can install what I want on this virtual machine. If I wanted to access a registry, I could. Configuration files, all that. I have full control. It's highly, highly flexible in that regard, right? But I also have a lot more on me, right? So I've got to worry about updating apps. I've got to worry about my antivirus definitions. I've got to maintain this virtual machine very similar to the way I would maintain a physical machine outside of the actual, disks and storage and physical side of it. But from the actual operating system and up, I've got to worry about maintaining that. Okay, so that there's virtual machines in the marketplace. You'll see for about every imaginable scenario, in addition to third-party scenarios in the Azure marketplace. Now, VM scale sets. This is an Azure compute resource that you can use to deploy and manage a set of identical VMs for scale out. So with all the VMs configured exactly the same, the scale sets are designed to support auto scale, and you don't have to do any pre-provisioning at all. So it actually helps you control cost in that regard, and then just to kind of automatically create a duplicate of VMs for a scale out scenario, which will likely have some sort of load balancer in front of that to be able to recognize that scale out. App services, these are services that you can quickly build, deploy, and scale web, mobile, and other apps running on really any platform. It is highly scalable, has elastic capabilities as well. And app services is part of a strong part of our PaaS platform. Azure functions are like compartmentalized code that's running completely separate from the underlying platform or infrastructure. So you can think of it as like serverless logic that's used to perform work in response to an event, a timer, or a message from another Azure service. let's talk about some of the network services. So networking in Azure allows you to securely connect cloud and on-prem infrastructure and services. And we have, first of all, the Azure Virtual Network. This enables many types of Azure resources, such as a VM, to securely communicate with each other, the internet, as well as on-prem networks. And a virtual network is scoped to a region. However, multiple virtual networks can be used together with virtual network peering. We also have an Azure load balancer, and we just talked about a little bit with kind of use with the VM scale set scenario. But the Azure load balancer can provide scale for your apps and create high availability for your services as well. Remember, high availability is that lens that the customer sees. So if my load balancer is connecting me to the correct, let's say, web component, but another one of those web components goes down, I can keep up the applications view to the consumer, and Azure Load Balancer helps provide that. VPN gateway is a specific type of network gateway, and the key thing here is that it sends encrypted traffic between a virtual network and over an on-prem connection to an on-prem location over a public internet connection. So the key thing to focus on there is that it has the ability to send encrypted traffic, and it provides a secure connection from on-prem to Azure over the internet. Your Azure Application Gateway, this is a web-based traffic load balancer that allows you to manage traffic to your web applications, and it's the connection to which your users are going to connect to your application. And I think uniquely to all these is a content content delivery network, a CDN. This is a storage account for documents and files that don't change often, but you want to use it kind of as a caching framework for media. So if you have a lot of media-based content and you're wanting to provide performance, the content delivery network is a really strong way of doing that to reduce latency. So let's talk about a little bit about the types of data, and then we're going to get into our storage accounts. So, okay, just checking time. Okay, so we have structured versus unstructured data. So structured is we're very familiar with this. This is SQL Server, this is Oracle, this is structured data is a very strict schema and has all the same fields and properties. We're very familiar, very used to these scenarios. Semi-structured does not necessarily fit neatly into tables or rows. Instead, we have tags or keys or other ways to try to identify the structure. We'll see this with NoSQL scenarios, JSON scenarios, log files, or not some CSV files where a particular column is not tightly populated. Maybe some cleanup is necessary as we pull in this data and we try to connect it to other relational stores. Unstructured data has no discernible structure whatsoever. Now, you may try to use cognitive services to make sense out of this data. Media like images, music, audio files, video. But in of itself, it has no predictable structure. It can contain any number of different types of data in its particular store. Now, this takes us to our storage accounts. So the first set that we see with Azure Storage is our blob store. And really, before I get into this, Azure, first thing you do is you're going to create a storage account. Okay, you can think of this as just like a container, and then once you create your storage account, then you have the opportunity to create what you see on the slide here. Okay, so blob storage, this is really kind of like a catch-all for anything that you want to place in the cloud, video, images, more. We actually use blob storage to house our virtual machines as well, which are page blobs. So, Azure Blob is unstructured. There's no restriction on the type of data it can hold. It's very scalable, and it works really in much the same way as you'd work with files on a disk, just where you can really put any type of material in that blob store. This storage provides storage for disk, virtual machines, and other services to use the store as needed. And these are page blobs that actually store the virtual machine files, as I mentioned. File storage is Azure block blobs over the SMB protocol that allows a file share extension from on-prem and virtual machines. You can kind of create sort of like a UNC path from on-prem to the cloud. I'm kind of a big fan of that approach, especially if you already have a really fast VPN or express route connection. And lastly, we have archival or archive storage. This is designed usually for large amounts of data. You're rarely going to access, and it's often used for compliance reasons. Like, you have to maintain 20 years of data. Now, I strongly recommend, just because you'll see this, is bring up the pricing calculator and take a look at the way Azure storage, these storage services are calculated. Archive storage is much different in that you're actually charged more to pull the data out than what you're actually storing. I think when I looked the other night for East 2, it was like just over $2 per terabyte to store it, but the cost comes in when you actually have to access the data and pull it out. So you're going to have these stores for these particular purposes and needs. And from a cost perspective, always use the pricing calculator, which will give you what you need to kind of be able to understand how they should be used. Okay, so let's talk about some of the data services. And there's a whole lot of data services to pay attention to. We don't have time to go through everything. I'm going to try to go over the key ones. Again, I recommend going through the portal and just kind of being aware of some of these and going through some of the tutorials. Nouns and verbs, right? This exam's like an inch deep and a mile wide. So just be aware of some of the key capabilities that these provide. First is Azure Cosmos DB. Think of like a planet scale. It's a globally distributed database service. Very, very low latency. It has full support for like Mongo, DB, and Cassandra-based apps. You can actually migrate the solution and then just change without changing any code at all. All you have to do is change the connection string, and you'd be able to connect to your migrated app. It has full support for Gremlin Graph, Table, and other APIs. So you'll hear people describe it as a planet scale low latency solution, NoSQL low latency solution, and it's a very strong scenario for those migrating of those applications, and especially net new development. So Planet mobile apps, anything where you need really low latency and you need planet-wide scalability. Azure SQL Data Warehouse, it's a cloud-based enterprise data warehouse that leverages massive parallel processing in order to run complex queries very, very quickly. If you're familiar with the parallel data warehouse, it's very similar architecture to what you see with BDW. You have a control node, with a scaled out 1 to 60 compute nodes. That's and how that scale is done is based upon the service level that's applied. The data and workload is done at the compute level, and we are in parallel. We are scaling out amongst those compute nodes in order to return data to the end user application very, very quickly. The control node is the brain of that operation. Now, all of that I just described, that's getting a little deeper than you really need for this exam. But actually, it's more in line with what you'd see with like a DP 200, the data engineering exam, that you don't want to know at that level, kind of like what does a control node do, and what does a compute node do, and what does the data movement service do, and how does parallelism work across? That's in the data engineering kind of framework. But you should be aware that it's an enterprise data warehouse that drives massive parallel processing workloads. That's a key piece here for that. And then we have Databricks. And the easiest way to think of Databricks, I think of it as Spark as a service. Okay, so Databricks offers a very managed version of open source Apache Spark analytics and data processing, fully integrated with Azure Active Directory. It's cloud-based big data, ETL capabilities, machine learning capabilities, and it's a first-class citizen in Azure. It works with all of our key capabilities, plugs right in, and it's Spark as a service is really, can just keep that in mind. It's a very Spark-oriented technology. So let's talk about from our SQL deployment options. Here's kind of the way the analogy I use quite a bit is I think of SQL Server kind of like a building, right? So a building has many rooms, okay? Just like a SQL Server will have many databases, right? And when I have a database on SQL Server, I have a lot of capabilities, right? I have access to a bunch of DMVs. I have access to the SQL Server agent. I have access to integration services and reporting services, everything under this umbrella, right? I have all kinds of capabilities when I have a database in a SQL Server, right? But what I'm getting in that database experience, most of it is coming from the server itself, right? So if I was to take a database and move it somewhere else, and if you see where I'm going with this, as it has to do with migrating an application from on-prem to the cloud. If you have an application that is driven for SQL Server, it was written for SQL Server, right? How many databases does that application use? Does it do a lot of cross database joins? Does it need the SQL Server agent job? Does it have an SSIS or DTS package that it relies on? Does it have global temp tables? Is it using some sort of CLR routine in there anywhere? If you think of those kind of things that your application relies on, that is running on SQL Server, you can kind of identify what technology you need when you're migrating that solution. Now, previously, anything outside of the database at all, like if I was to pluck a room away from a building, I would lose air conditioning, right? I would lose power, I'd lose plumbing, I'd lose a lot. I could lock the door to the room, but everything I relied on outside of that room that came from the building, I would lose. I would have to find another way of solving for that, right? That's the challenge we had with SQL database. So when moving our application from on-prem to the cloud, if I needed anything outside of that SQL database, I would have to find another way. Data Factory for my ETL, Power BI for my reporting, Azure Analysis Services, the semantic layer for my, what I'm doing. Maybe I also need Azure Data Warehouse. But you have a vendor-based application, that migration quickly becomes a challenge. They're not going to support it. This is where we have managed instance. Managed instance, the code name was Cloud Lifter. So that's sort of like the analogy I used before, is moving a room, right, from a building to another location. This is like moving the floor that has a purpose. Like, marketing's on the third floor, or sales is on the fourth floor. Imagine that I could move the entire floor, but I keep air conditioning, I keep my power, I keep my Wi-Fi, I keep everything I need to operate as contained on that floor. So for the application's purpose, I keep all that stuff. I keep my agent jobs. I keep CLR. I can do my global temp tables. I can do my cross database joins. That's what managed instance gives us. And we're well familiar with what a SQL Server on IaaS is. Whether it's Windows or Linux, SQL Server can run on it. We're familiar with running IaaS machines, but really kind of think of in this is the building analogy. That's kind of something I came up with, but it helps me understand database to manage instance to actual SQL Server. This is why also I said, and I think I said this before, Azure SQL database or PaaS-based technologies, perfect for net new development and stretching outside of a migrated solution. If you're trying to migrate an app, managed instance is awesome. Perfect for that scenario. It's what it was designed for. For everything else, if you need full control, full flexibility, SQL Server on IaaS is your preferred deployment option. And again, you're not stuck with any of these decisions. If you think from a software as a service perspective, a consumer perspective, get your solution up there, whether it's managed instance or IaaS, and you can work towards a more PaaS-based model over time, where you can take advantage of hyperscale, where you can take advantage of serverless compute, where you can take advantage of all these other things that you see being added in and evolving with Azure SQL database. It's kind of the approach or the mindset that I like to have. Okay, so let's talk about a little bit about IoT. So the internet allows like any kind of information to be analyzed and collected in high volumes. You see mentioned here is Azure IoT Hub. When I think of IoT Hub, I think devices, and when I think of like an event hub, I think applications. It's kind of the way I sort of put it. In terms of Internet of Things, in terms of IoT, in terms of devices, IoT Central is a fully managed Internet of Things software as a service solution that makes it easy to connect, monitor, and manage IoT assets to scale. So you can bring your products to market much faster and stay focused on the customer experience. Again, like I said, think about applications, tie that to like event hubs. Like let's say if you're doing analyzing, let's say Twitter sentiment data, you're processing, that'd be perfect for an event hub scenario. An IoT hub is used for devices, let's say like a bike that has sensors on it, or weather, air quality sensors, where you're trying to track and analyze real-time analytics with a high scale around those devices. That would be perfect for like an IoT hub scenario. So this is a service in the cloud that acts as a central hub for bi-directional communication, and that's a key thing to be able kind of point out between your application and the devices that you're managing. An IoT hub can be used to kind of build this reliable and secure communications between. You can have millions of IoT devices, and it will be able to handle the scale for those scenarios. For artificial intelligence and cognitive services, artificial intelligence in the context of cloud computing is based around like a range of applications, including machine learning, and this is all around. You'll see this quite a bit. Predicting, taking data and making a prediction, forecasting, analyzing future behaviors, or analyzing an outcome, or making a trend aware across the data points that you have. And what we have here is we're talking about the machine learning service. As you may have heard people say that fail fast and learn while doing so, right? This is like the laboratory analogy of experiments that yield some sort of results. So we're constantly rerunning tests and creating solutions where, again, we're predicting outcomes. And what we want is an increasing improving rate of accuracy. Now, most machine learning solutions, where we get into like the guts of it, you see people using R or Python to build these out. Well, Azure supports both of these scenarios. So where you can use machine learning services to develop, train, test, deploy, and then track these models to make sure that they're performing correctly. Machine Learning Studio, this is an attempt to make this much easier, lower the barrier of entry. You see that mentioned quite a bit. So it's a drag and drop collaborative visual workspace where you can build, test, and deploy solutions, but you don't have to write any code. So there's a lot of pre-built and pre-configured machine learning algorithms and modules to help you do this. So if you want to experiment with machine learning quickly and easily, you'll see built-in machine learning algorithms in order to help you accomplish this. And not on the AZ900 exam because it's not Power BI focused, but you see some of these capabilities have been introduced. I think in the past year, you'll see some of these capabilities introduced to Power BI. Azure Cognitive Services, these are services that are available to help developers build applications without having to write any specific AI or data science scenarios. The Cognitive Services enables developers to add features into their apps like vision, speech, language detection, web search, decision-based scenarios, and more, right? So analyze these images and apply tags to them. Tell me, look at, listen to the speech and then able to identify who the speaker is, or any number of these scenarios. You don't have to build those components, but the Cognitive Services gives you these tools so you can apply this AI to your applications that you're creating. So DevOps and Dev Test. DevOps allows you to create and build pipelines for continuous integration, delivery, and deployment of apps. It's an integrated solution for the deployment of code. DevOps provides development collaboration tools for high performance, Git repositories, and a lot of automated and cloud-based load testing scenarios. Azure Dev Test is a service that helps developers quickly create environments in Azure, minimizing waste and just really controlling costs. So you can develop apps very quickly, be provisioning Windows or Linux environments, and have reusable templates to make that a very controlled scenario. Key thing is like reducing overhead and being able to automate shutdowns to minimize cost, whether it's a Windows or a Linux-based environment. So from a monitoring perspective, there's a lot of strong capabilities here. Azure Advisor, my favorite capabilities in the cloud, is a portal tool that provides guidance and recommendations to improve your Azure environment. You can get actionable best practice recommendations, security, performance, high availability, and cost analysis. And you can download this in like a PDF or a CSV format. They're constantly adding stuff to Azure Advisor. You can also get alerts at this point. It's just right into the portal. So you'll see some of the PaaS capabilities will have a link to advisors. In other words, what is Advisor saying about this PaaS component? But I think that the strength around Azure Advisor is sort of that, some of these things you just hear, but it's true, right? Like single pane of glass. Yeah, it really is. It really is a single pane of glass. It really tells me these are your risks that you have across your environment, and this is what you should really focus on first: high, medium, low. And then, when I deploy this scenario, when I, hey, you should enable TDE on your SQL databases, right? You have some network connections that are not in a network security group. You have some scenarios where you should be doing data classification. You may have some sensitive columns in a particular database that could be exposed. Where you could maybe use always encrypted or dynamic data masking to obfuscate what's being sent back to the user. All of those kind of things are seen because your metadata around your solutions is working for you. And Azure Advisor is giving you really a simplified way of seeing it everything from a very high level, but then you can drill down and get into the details as you need. It's really cool stuff. Now, related to that is Azure Monitor, and this has definitely evolved over time. Use Azure Monitor to collect and analyze telemetry data. We have metrics that are a part of this that think of like perfmon, right? If you're familiar with perfmon, use perfmon. I can alert on these metrics, like when CPU goes over a certain amount on a VM for a sustained period of time. If I get too many errors, too many faults, too many failures, give either log or alert me. That's what these metrics are doing. But I also have log analytics. Log analytics, it's got a tool, I call it a tool in the slide, but the capability to basically query the log queries. You can actually create alerting there as well. And you'll see that we have a custom query language approach. It really looks like T-SQL to be able to dig through your logs and actually kind of give you some insights of what's going on in your environment in addition to the metrics and alerting. And we also have a part of this Azure Monitor space is application insights. And it's a performance management service for developers to monitor your living web applications. So detect performance anomalies, latency scenarios, help you diagnose these issues as well. And that's kind of all in the space of like Azure monitoring. So what are our management tools? Well, portal.azure.com is our Azure portal. This is our core web-based platform for accessing Azure via browser. We're going to see much of the capabilities we've talked about in the lens of Azure, the Azure portal. If you want to use PowerShell, absolutely can. You can use PowerShell from like an on-prem based connection or a scheduled based scenario, or amongst any of the services that you have in the cloud. You also have the Azure command line CLI based tool. You can see this in the downloads for a cross-platform command line option for Windows, Linux, or Mac OS. Now, the Azure portal is going to be available to any browser, HTML5 compliant browser. The Azure Cloud Shell is also directly in the portal, where you can actually run your PowerShell or your bash-based scripts directly through the portal as well. So also from any browser experience. Right? And I'm telling you that specifically because definitely be aware that the Azure portal and the Azure Cloud Shell are both browser-based scenarios. That's going to give you a lot of flexibility for where you run your code. And also the Azure command line interface is a cross-platform solution. You're going to download this tool, but it will run on Windows, Linux, and Mac OS. Okay. So a lot of flexibility of where you can actually run your PowerShell script solutions. So we're going to talk a little bit about, and I'm watching the time, I've got about 20 minutes, around security, privacy, and trust, and we're going to talk about Active Directory a fair amount here. So there's two core concepts fundamental to understanding identity and access, and this is the authorization and authentication and authorization. First and foremost, authentication. This identifies the person or service that's trying to access a resource, where authorization determines the level of access that they should have. Okay, so you can in any scenario, and we see this a lot, even on-prem, whatever the scenario is, you can use any number of application-based security situations. A lot of vendors like to go with this approach where the database has got salted password and the accounts that they're managing everything. We also have SQL-based authentication. It's another common method for SQL-based workloads. However, Azure Active Directory is by far the most secure means of driving identity access management for your applications in Azure, and it's also Active Directory is the most secure approach on-prem. And so Azure Active Directory is going to be the most secure approach in the cloud. And there's a number of reasons for this, but outside of what we get just directly from Active Directory, there's other scenarios as well, such as like self-service, user password reset, multi-factor authentication, customized banned password lists, smart lockout services, and so forth. Single sign-on, users only need one ID and password to access. It's fully audited scenario, fully controlled. Application management situations where you can manage cloud and on-prem apps using Azure Active Directory's application proxy. And in particular, I kind of want to focus on multi-factor authentication. Use it at Microsoft all the time. This provides additional security layer for identities requiring 2 or more components for full authorization, right? And this is broken down in something could be a password key, could be a password that you've written, you've done, something you possess. So it could be a device that you wear in your wrist. It could be your mobile device, something where you're going to respond to the authentication, and something you are, something about you. This could be your fingerprint, your voice signature, a retinal scan, whatever it may be. And that in combination is what multi-factor authentication is driving towards. A very key capability that you get from Azure Active Directory services. It drives a lot of the security that we have in that regard. And so for some core security components to be aware of is Azure Firewall. So, for like SQLDB that's integrated, data warehouse, other technologies that are integrated, you'll see like a simple whitelisting of IP addresses or IP address ranges. Azure Firewall as a standalone product provides more. It's inbound protection for non-HTTPS protocols such as like FTP and SSH, outbound network protection for all ports and protocols. There's additional capabilities that you're going to get in Azure Firewall, but kind of look at this as a first step from a security perspective. So turn on the firewall. Network security groups. If you're trying to say like, look, I only want these web servers to connect to these database servers, and I only want them to do this in a very particular way, then you want to use a network security group. This lets you set inbound and outbound rules, and you can filter by source and destination IP address, ports, protocols, and it's very specific to that purpose. Where application security groups, this is the same concept, but in lines with a workload. So this is the grouping of servers with similar port filtering requirements with similar functions like web servers, database servers, right? And application security groups allows us to reuse policies without manual maintenance of having to deal with explicit IP address or any kind of complex rule set. So you can really focus on the business logic and your particular workloads. So similar concepts, but specific purposes that these technologies are going to have. Not going to go through all. There's a lot here. So you can think of transparent data encryption. TDEs like BitLocker for your databases, right? It's going to protect your databases, database files, TempDB, and any of your backups. Dynamic data masking obfuscates. It does not encrypt. This is important. Dynamic data masking does not encrypt anything. It's like a function that obfuscates what's being sent to the user, where always encrypted does encrypt. You can store those encryption keys in an Azure Key Vault. but this will help you encrypt over the wire. So any kind of man-in-the-middle attack will be thwarted by always encrypted. Have a lot of capabilities like assessment wise, data discovery, classification, vulnerability assessment. It's all kind of in the advanced threat detection space, where advanced threat detection is leveraging machine learning and your heuristics. What does it look like? Does this look like a risk? Does this fall outside of the norms? Does this look like a SQL injection attack? Is there any kind of data exfiltration scenarios going on here? Is an unusual login pattern? I'm not used to seeing a whole bunch of IP addresses for coming from that particular location. Any kind of thing like that, advanced threat detection will help you find. Row level security is all about limiting at the record level based on an inline table valued function of what you should be able to pull and see to the calling user. Again, I mentioned the firewall whitelisting capabilities. Use Azure Active Directory. Yeah, always. We can't stop vendors from what they do, but we can certainly suggest it. And Azure Active Directory is far more secure. And of course, we have full monitoring. We have the Security Center. We have Azure Advisor and the plumbing underneath for Azure Monitor. And you got that single pane of glass, and you're able to drive this down through the Azure Security Center. It's really powerful. Huge fan of this from not just from a SQL store, from our structured approach to our NoSQL store, Cosmos DBs, or MySQL, and all kinds of other capabilities that we have from a platform as a service perspective. You're going to get all of that. Now, it's going to differ, right? How does Azure Data Warehouse do this versus SQL DB? For the purposes of AZ 900, you don't have to get into the myriad of different approaches from a security perspective per platform as a service building block. Be aware of what you can do, especially the standalone components. And that's my advice on that. Some compliance, I definitely recommend going to the Compliance Center and just being aware of the key ones like GDPR, NIST, the Criminal Justice Information, HIPAA, Health Insurance, Portability and Accountability Act. By the way, if you see they start referring to PHI data, that's going to fall in line with HIPAA. If you see PII data, personally identifiable information, that's probably not in line with that kind of approach. PHI matches with HIPAA, but from a government perspective, FedRAMP, FedTech, PCI. So go through the compliance and just be aware of some of the compliance offerings in some of the scenarios that are referenced there. That's my advice on approaching that. I think we've mentioned a little bit about the Security Center. Look, Security Center, first and foremost, that's different from Advisor. It's going to give you a security score. And it's kind of like a credit score. But you look at these risks. These are the big risks. You got to address this, right? You have this huge red flag on this particular item, right? If you address that item, address that piece, and here's the remediation that you need to do. In many cases, you click a button and it applies it for you. Like, hey, turn on TDE for this particular component. And I see that I've right at 10 minutes, so I'm gonna have to go quick to wrap this up. You're gonna want to take and go after kind of your big items. Azure Security Center, much like Advisor, gives you a single pane of glass to be able to do that. This is some Azure security best practices that I sort of put together because it was so much to go through, and I was going to have a million slides if I didn't kind of break this down. But just in time virtual machine access. I think we mentioned advanced threat protection at least loosely. Azure policy is kind of like the rules that you can set. Like I'm not allowed to create a database without TDE enabled, for example. Let's just say. Or at least flag it. It doesn't stop something from happening, but it will flag it. Using Azure Key Vault, especially that would be perfect to do with always encrypted scenario. Leverage Azure information protection to protect scenarios. Let's say if you have a credit card number that happens to be in a Word document, flag it. Make sure that label that for me. DDoS protection. It's sort of like to help you from like volumetric type attacks, flood-based attacks for your application, and your web-based application firewall for internet-facing ports, and do some segmenting using network security groups. We talked about that earlier. So be aware of these kind of best practices for your environment. For Azure support and pricing, Azure subscription, look at it kind of like a resource group. The logical construct groups resources together, tie subscriptions to an account, and you're billed at the subscription level. I can have a resource group, a bunch of resources in different subscriptions. I will tell you that one of the key things to do is definitely leverage tags to help you track, maybe at the project level or application level, as you have a whole bunch of resources scattered around. It really kind of helps you, not only from a monitoring perspective, but from a billing perspective. But your Azure subscription, tied to an account, and it's this construct that helps us. That's what and it's also how you're billed for what you're doing in the cloud. We talked about doing that free account. If you do a free account, I think you get it's $200 for 30 days. When that trial is done, you can upgrade it to a pay-as-you-go subscription. Just give it kind of a method, a billing method. And there's some, selection of free services that you get. By the way, a really quick tip: if you go into the Azure portal, if I had time, I'd do demos and everything. Go into the Azure portal, and at the top bar, just type in free, FREE, and it will give you a list of all of the free services that you can do, that you have access to, and it will describe what your capabilities are. Even people that have been using Azure for a really long time were like, whoa, I didn't know this was here. So yeah, you actually have a way of tracking that. Be aware that when the time runs out, or your $200 runs out, Microsoft doesn't delete anything; it just disables the service. As you're creating solutions, you have management groups, you have subscriptions, you have resource groups. And remember, I told you these are your containers, and you have resources. I mentioned tags. This is, it's almost like a hashtag. I think you can have up to 12 or 15. I think it's 15. You have 15 of these, and you can say hey, this is this is my project, my app, or whatever. But it allows you to track this stuff. And I like the idea of being able to track it at an application level. There's also the concept of locks, and what locks allow you to do, resource group and down, is it's sort of like a speed bump. I don't want anybody to accidentally delete or modify something. You can manage the locks at your subscription or resource group, or even at the resource level. Support plan options, I definitely recommend pulling this up and comparing them. Developer, standard, professional, and I was a PFE. I was a Premier Field Engineer for a while, came out of the Premier org, okay? And what do those plan options, how do they compare? If I needed to have someone on the phone, which option would I use? If I needed quick response, which option should I use? I would strongly recommend to kind of walk through what your plan options are. The other thing too to be aware of is, how do I open a support ticket? How does that process work? So choose help and support in the portal. You go to a new support request. Recommend walking through that. You don't have to commit and send it in. If you actually have a problem, then we'll send it in. But you don't have to commit and send it in. So you can kind of walk through it and just realize that you're actually doing that in the portal itself. We have service level agreements. We actually have composite service levels. Like if I have a web service that is 3 nines of availability and a database service is 4 nines of availability, how you're going to calculate that out, right? And you're going to see what that composite looks like. Just be aware of your service levels and that they range from 3 nines. You can actually have up to 5. Cosmos DB has 5 nines of availability if you do multi-master rights. Pretty cool stuff. So just be aware of the service levels, and these continue to change. If you're looking for your Azure updates, you're going to see this improve over time. Again, I plugged the pricing calculator. Definitely pay attention to this thing. This is the way to go to kind of get a gauge of what it, not only from a migration perspective, there's also the total cost of ownership calculator. So if you're trying to say like, look, this is the square footage I have in my data center. This is the staff that I have, and all. If you're really trying to get granular and trying to say like, look, this is what it's going to mean for my organization moving to the cloud, go search, Bing, Google, whatever your total cost of ownership calculator. But for services, like I'm creating a resource, I'm going to use Premier storage. I'm going to use spinning disk. I'm going to use local redundant storage versus, geographically redundant storage. This is how much data I'm going to have. This is, do I need an archival account, et cetera, et cetera. Use a pricing calculator to get a good judge of that. And then when you're actually in your scenario, use the cost and budgeting capability to look at your trends. Like I can even say, what is my most expensive resource in the past 7 days? What does the trend look like? It's really good at that. So use those scenarios together. Minimizing cost, just use, like I said, use some pricing TCO calculators. Monitor usage with Azure Advisor, and really pay attention to what Azure Advisor is telling you from a cost perspective over time. Right? They'll tell you like, hey, look, you've got VMs that are way underutilized. You could actually shrink these down. Use Azure reservations. Another tip. Here's another tip. Go when you're in the portal at the very top, just like I told you to search for free, right? Type in reservations, and it will actually list all of the technologies that we have where you can use a reservation. Like I think Data Warehouse, Cosmos DB, certainly for virtual machines, but there's other ones as well. You might be surprised what you see there. Careful with picking, like, you got to pay attention to egress costs as well. Be smart about when you're picking a region, a low cost location or region. You may want to kind of balance between East and East 2, but don't go crazy and have like a website way over here and a database server way over there. That doesn't make sense. It doesn't make sense from an availability perspective either. So, pay attention to the cost per region. You'll see that in the pricing calculator. And also, of course, you apply tags so you can track this stuff over time. I am at time. I actually hit the last slide. This is my additional references and resources. I just started putting stuff together, things that I thought you'd be interested to have, including the Twitter support. You'd be surprised the responses you get from Azure support and Twitter. And hopefully this is very useful. Good luck on the AZ900. I know y'all all do awesome. And were there any questions? I didn't leave time for questions. I went right to the bell. But was there any questions?
Yeah, we have some questions. Hopefully you can hear me. Yeah, we have some questions, and I can stick around for a few minutes if you can as well.
Yep, I have about like 5 minutes or so. I can move. Okay. I have another meeting, but I can push.
Sure. So here's the first one. Is there a security support matrix for this, i.e. what supports AD, AAD, or SQL regarding SQL Server deployment options?
Trying to understand the question. Can you say that one more time? Because I'm not fully understanding that one. It's not that, sure. I don't think that would be on this exam. It might be on AZ500. That's more of a security. Okay. But give me the question one more time.
Sure, and the question is regarding SQL Server deployment options. Is there a security support matrix for it? Does it support AD, AAD, and only SQL?
I would have to look into if there is something that is documented like that. That's a good question, but definitely wouldn't be on the exam. But I would have to see, is there like a support matrix for? And there's a follow-up question to that too, because what that does is actually gets me thinking, like, so what AD services are supported across the wire too? Because you could ask that as well. That's a really good question. I'd have to look that up. That's actually a really good question. Like this, is there something that wouldn't support single sign-on? Is there something that wouldn't support, right? So yep. It's a good question.
Okay, and this next one. I kind of know, I have a feeling what your answer is going to be, but I'm going to ask it so that everyone can hear it. So somebody has the AZ900 exam next week, and they were wondering what types of questions they can expect, more MCQ type or descriptive with stuff to write.
So here's the thing: the exam changes all the time. So if I take it, you're going to get, pools of questions. Um, I can't say. What I would say is that definitely, like, if you're looking for an exam kind of like test, what's out there these days. I think Measure Up has some stuff, and you may see other engines like that. They're never going to give you the exact question and answer, but they're going to give you kind of similar stuff that's based on what you see in the test portal. I can't remember because I take exams all the time. So like you're probably going to see a mix of all kinds of different types of questions coming at you. But I don't believe it's a performance-based exam. So that I don't think it is. Unless that's been added since I've taken it, I do not believe it's a performance-based exam. In other words, like you have to go in the portal and deploy something. I don't think it's like that. It's non-technical, and it's more around, like I said, an inch deep and a mile wide around your products and services.
Right. And then does Trust Center support GDPR?
The right to be forgotten. That's the way I always look at it. Does the Trust Center support? I would have to look that up. I don't know specifically, but it's definitely. There's definitely some resources out there. Let's see. Do I have it on here? I'd have to go to the Trust Center. I was looking to see if I had like something specific to GDPR. I would go and just look that one up. I don't know for that one specifically.
And this is probably the last one that we have time for. Can ALA send an alert?
Can Azure log? Yes, you can. You have log analytics can send an alert. You can even do alert groups. What's really cool about the way they have that set up is I could like notify a team like, hey, this is something that's found. My KQL query found an issue, or my metric found an issue. You can create an alert group. You can even send it to like an ITSM kind of based scenario. You could actually kick off an Azure Runbook. Some of the stuff we didn't have time to cover, but it is really deep what you can do with log analytics in the monitor space, and they actually have some really good tutorials out there. But yeah, and look for an alert, like an alert group when you're actually, once you define your metric, start with like a metric, and you'll see like it's easier to get to the alerting that way. But you can do some cool stuff.
Excellent. Well, that's kind of about as much as we have time for today. Thank you, everyone, for attending. And thank you, David, for presenting. And for folks that are looking for more cloud sessions, we do have another session tomorrow and 2 more next week, and so on and so forth. So please be on the lookout for those. And just thank you, everyone.
All right. Thank you very much. All right. Take care, everybody.
Yep. Bye.